Hello everyone, welcome back. In our previous videos, we discussed what open source intelligence is, how reconnaissance works, and how publicly available data can be used in investigations. Today, we are going to apply that knowledge to a real-world use case. In this video, we will understand how vehicle-related information can be analyzed using a vehicle registration number, strictly using OSINT techniques and publicly accessible sources. Before we go further, let me make one thing very clear. This video is created purely for educational purposes. We are not hacking into any database. We are not bypassing security controls. We are not accessing private owner details. We are only working with data that is already publicly accessible and legally available. Before we move to the practical demonstration, let's quickly understand the type of information that is typically available through legitimate vehicle lookup services. Depending on the source, you may find registration date, vehicle model, fuel type, registered RTO, insurance information, registration city. Let's move into the practical session and see how this works in a real environment. This tool supports multiple platforms. It can run on Termux, which is commonly used on Android devices. It works on Windows systems. It supports Kali Linux, which is popular among cybersecurity professionals. It also runs on Ubuntu and Debian distributions. Parrot OS is supported as well, and even Arch Linux users can run this tool. So basically, this tool is cross-platform and can work on most operating systems that support Python and Git. But for today's demonstration, I will be using Windows, and I will clone the tool using Git. The reason I am using Windows is simple. Many beginners and learners use Windows as their primary operating system. So this setup will be easy for most of you to follow. Now let's quickly understand what we are about to do. Now that we understand the supported platforms and the environment we are using, let's move to the practical demonstration. I will now switch to my screen and start the setup process. First, click on the Windows search bar and type Git. From the results, open Git Bash. Git Bash gives us a command line environment where we can run Linux-style commands on Windows. Once the terminal opens, I type the command ls. The ls command is used to list the files and folders present in the current directory. Now we will change working directory. First, I switch to the D drive by typing D: and pressing enter. This moves us from the current drive to the D drive where I want to set up this project. Next, I type the command clear to clean the terminal screen. This removes the previous output and gives us a clean workspace. Now I create a new folder for this project. I type menkdr vehicle OSINT and press enter. The menkdr command stands for make directory. It creates a new folder with the name vehicle OSINT. To verify that the folder was created successfully, I type ls again. As you can see, the vehicle OSINT directory is now visible in the list. Now I will navigate into this folder. I type cd vehicle OSINT and press enter. Now that we are inside our project directory, the next step is to download the tool from GitHub. To do that, I use the command git clone, followed by the repository URL. Git clone allows us to download the complete source code from the repository to our local system. After pressing enter, Git starts cloning the repository. This may take a few seconds depending on your internet speed. Once the cloning process is completed, I type ls to list the contents of the current directory. As you can see, a new folder has been created. This folder contains all the files related to the tool. Now I will move inside the cloned folder. I type cd followed by the folder name and press enter. Now we are inside the tool directory. Before running any Python-based tool, it is very important to check the requirements file. This file contains all the dependencies or libraries that are required for the tool to function properly. So I type clear to clean the terminal screen for better visibility. Then I use the cat command followed by requirements, txt. The cat command is used to display the contents of a file directly in the terminal. As you can see, this file lists the Python libraries that need to be installed. If we skip this step, the tool may throw errors because required modules would be missing. Now I will install all the required dependencies in one single command. I type pip install -r requirements.txt. The -r option tells pip to read the file and install all the packages mentioned inside it. Press enter, and the installation process begins. This may take a few moments depending on the number of libraries and your internet speed. Once the installation is complete, I type ls again to confirm all the files are still present and our environment is properly set up. Now that all the dependencies are installed successfully, we are ready to run the tool. To see the main usage of this tool, I type the command Python vehicle OSINT to py and then press enter. As you can see, the tool is now loading. It initializes the required modules and prepares the interface. Once the tool is fully loaded, it prompts us to enter a vehicle registration number. For demonstration purposes, I will enter a random vehicle number. After typing the registration number, I press enter to start the lookup process. Now the tool begins querying the publicly accessible data sources. Within a few seconds, the results are displayed on the screen. As you can see, the tool is returning structured information related to the vehicle. The output includes details such as vehicle registration date, registration name, father's name, registered RTO information, fuel type of the vehicle, insurance type, insurance expiry date, associated phone number, and registered place information. All this data is formatted clearly, making it easy to read and analyze. This demonstrates how automation can quickly collect and organize information that would otherwise require manual searching across multiple sources. Again, it is very important to understand that such tools must only be used for ethical, educational, or authorized investigative purposes. Misusing personal or vehicle-related information is unethical and may violate legal regulations. From a cybersecurity perspective, this example also shows how exposed data can be aggregated and structured using simple automation techniques. And this is how the main usage of the Vehicle OSINT tool works in a practical environment. Now, let me run the tool one more time for demonstration purposes. Again, I type the command Python vehicle lookup, py, and press enter. As you can see, the tool loads successfully and now prompts us to enter a vehicle registration number. This time, I will enter another random vehicle number just to show that the tool works consistently. After entering the number, I press enter. The tool starts processing the request and fetching the related information. Within a few seconds, the results are displayed on the screen. We can again see structured details such as the registration date, registration name, father's name, registered RTO, fuel type, insurance information including expiry date, contact number, and registered location details. This confirms that the tool is functioning properly and retrieving the available data in a formatted way. Remember, this demonstration is purely for educational and awareness purposes. Always use OSINT tools responsibly and ethically. Thank you for watching.